Thank you very much, everyone. This is joint work with my colleague Marina, who's in the audience. Sorry, how does this work? Okay. Oh, not back. Yeah, and before I continue, usual disclaimers apply that our work is our opinion only and not that of the IMF. So our presentation will focus on something that has been in the news a lot recently, which is artificial intelligence. And if you read the news, you probably saw some kind of article talking about the kind of disruptions and opportunities that the fast applications and development of these technologies might bring to the labor market. So the focus of this presentation is to bring some of the discussion together with the kind of issues that have been the focus of this seminar, of series, and in particular with a view to encouraging longer working lives among elderly workers. And of course, the objective of the presentation and our work is not to give very definite predictions of what's going to happen, but to give some kind of points and lenses through which the two topics can be understood together. And so the first part of the presentation the first question that we answer is, overall, relative to other groups of workers, are older workers more or less predisposed to make career changes and potentially adapt to the kind of structural change that artificial intelligence might bring to the labor market? And for that, we're just going to look at some broad indicators of what can be called labor market fluidity, such as how often do older workers change their jobs, their industries of employment, and occupations that can be seen as kind of a potential for making changes in career trajectories when structural transformation happens. And this is kind of a broad view, and then we'll go specifically into what kind of opportunities and risks can artificial intelligence bring to the labor market, and are older workers more or less exposed to these risks relative to other groups, age groups. And to do this, I'll first bring in a kind of a conceptual framework in terms of which occupations can we think of as being more or less exposed, both in terms of the opportunities and the risks. And we'll think here about the kind of structure, usual framework that has been used also for, say, routine bias technical change of which jobs are more complementary versus which jobs are more exposed to substitutions. And also we'll talk about whether these kind of jobs are more likely to benefit from artificial intelligence and potentially grow in labor demand are also conducive to longer working lives. And then here we also want to make a distinction between the current generation of older workers versus future generations of older workers, just because structural transformation in the wake of new technologies doesn't happen all at once. You don't wake up one morning and suddenly you have a world run by AI, but it's something that takes decades as new technologies are progressively introduced into the labor market. So that means that our workers who are being potentially affected now, and their career trajectories will change in such a way that when they become old, they will look very different from the current generation of older workers. And then very quickly, if time allows, I'll talk about an indirect channel through which AI may affect labor supply decision, which is the wealth channel and returns to equities. For most of the presentation, I'll be using very standard labor force data from the US, from the current population survey, the American Community Survey, and the census data. And again, it's hard to make very, use arbitrary thresholds to define who's old and who's not, but we'll generally define older workers as those aged 55 to 69 for analytical purposes, and sometimes we'll compare them to younger and prime age workers. And the focus of all the charts will be on male workers, but in the appendix of the paper we have exactly the same charts for females, and all the results are very similar. As I said, the first starting point is how dynamic and how fluid is the labor market of older workers relative to younger workers, and hence if we think that there might be a very large kind of structural shift in the type of jobs that are in demand, how are these workers predisposed to take advantage of those jobs, and also to move away from the ones that potentially have more disruptions. And here, essentially, I'm just plotting different transition rates from across states of the labor market. So for instance, the job finding rate is the probability that somebody who's unemployed by next month has a job. And we can see that for older workers, both with a college education or without a college education, this rate is lower than for younger and prime age workers. Separation rates, on the other hand, are the rates at which workers move away from the current job and move into non-employment. This is a bit harder to interpret because it also includes both voluntary and involuntary separations. But overall, what we can see is that historically, older workers are both less likely to lose their jobs, they're also less likely to voluntarily move away from their jobs. And then we have 3 indicators of kind of fluidities within employment, so job-to-job rates, so how often workers move from one employer to another, occupation switching rates, and industry switching rates. And in all cases, we see that the labor market experience of older workers is very much characterized by less career changes. And this obviously makes sense if we think of older workers having found their career path, having reached kind of like their peak in terms of earnings and knowing where their comparative advantage is, and they don't have to find another job. But there is also an aspect of this as being potentially less prepared to having to make forced changes because it's something that is not inherently in their current kind of career experience. As I said, what I've discussed so far is just generic. It's not specific to AI. And as this is something that is still happening, it's really hard to know exactly what the impact of AI is going to be on specific jobs. But what the literature so far has done is to use a framework similar to that used by those who studied routine bias technical change, which is to think of occupations essentially as a bundle of tasks or as a bundle of abilities, and then try to understand how those tasks and abilities are interact with where AI is, what is it capable to do and where is it being applied. So for instance, there is a measure of exposure at the occupational level by Felton and others that looks at the overlap between AI applications and the key and essential abilities that are needed to perform a certain jobs, which is, I don't know, hand-eye coordination, or being able to write well, creativity. And this measure is kind of agnostic to whether this application of AI is going to be substituting for the work and the tasks performed by the workers or complementing a worker so that AI would essentially be kind of supervised by a human being. So what Marina and I do in a companion paper is that we think that some of these concerns about whether the AI would be supervised or unsupervised really have to do with the social context of jobs and the level of education and trainings that workers need. So what we do is that we use the similar data set that has been used to define exposure to use what is a different dimension of this data set from, which is called ONET, which for every occupation has measures of essentially context of the job, such as the criticality of the decisions that are taken, the responsibility for others, the consequences of potential errors, human interactions, the level of training that is needed. And the idea is that we try to capture social preferences and ethical concerns about AI to come at a measure, to reach a measure of complementarity. So I'll be happy to talk about this more later, but basically for the presentation, for the sake of speed, basically what we do is that we divide jobs into those that have a high exposure, so that's a high scope for application of AI, but a high complementarity, meaning that workers in those jobs are more likely to use AI as a tool that increases their productivity. And then jobs that are high exposure but low complementarity, meaning that there's a high scope for application of AI as a substitute technology. And then the low exposure jobs, which are jobs where potentially there's not much scope for the use of AI. And here what we see in the graph is essentially on the x-axis this AI exposure measure and complementarity on the y-axis. And to give you a very simple example of how these two measures interact, we can think of a career stream like the legal professions, where you have legal assistants, judges, and lawyers. And essentially, the kind of skill, the kind of tasks that a legal assistant and a lawyer do, they're not very different in the sense that they're using text. You know, you read, you write, you search for information, and you process it. and apply to new cases, but a legal assistant has less independence in their decision, much less responsibility, is not client-facing, doesn't take personal responsibility or personal decisions, but it's also less critical compared to a judge and a lawyer. And so that's why both jobs are highly exposed, but the level of complementarity is different, and we can think of legal assistants as being more exposed negatively to AI. So of course, this is very indicative. It's not making an absolute prediction about which jobs are going to be affected, but roughly speaking, it gives us kind of a framework to understand these groupings. And it's also important to know that when we think of complementarity, it doesn't mean that all the workers who are in those jobs will benefit. It will benefiting from AI will be conditional on having the skills that are needed, which can be very fundamental, but in some cases it can also be just general AI literacy and understanding of how it applies to the concept of your own job. So if we are to plot the share of employment in these different occupations by age, separately for college educated and non-college educated, we find some interesting patterns. First of all, I'll start from the college educated. We see that older workers tend to have a higher share of employment in high complementarity jobs and a lower share in low complementarity jobs compared to younger workers. But really, they reach their, over their careers, they get there by switching jobs and switching specifically out of the low complementarity jobs into the high complementarity ones. So we can reconnect this to the kind of high fluidity of labor markets for young workers as they move up their career. So kind of a priori, we can say, okay, within a given occupation group, older workers are more predisposed to benefit from AI because they're in a higher share in the jobs that are more likely to see improvements in labor demand and productivity. But also if we compare the educational level, we also see that it seems that overall the kind of educational dimension is more important than the age dimension. Now the question is, do these jobs, are they better than the jobs that are low complementarity? Are they going to be conducive to higher, to longer working lives? Do workers benefit by being here? And here the picture is a little mixed. So what we do here is that we just plot for workers age 55 plus certain job characteristics across these occupation groups. And what we see in the first figure is, the first panel is that, okay, average earnings are higher in high complementarity jobs, both relative to the low complementarity and the low exposure jobs. And this makes sense if we think that these high complementarity jobs are those that have more responsibility, more independence in thinking and in deciding your own tasks. So it makes sense that they're usually the ones that are more rewarded, and also we saw the high education workers tend to be in these jobs. On other characteristics though, such as the type of work modalities, there is not much of a difference between the low complementarity and the high complementarity. So for instance, work from home shares are very similar. So this is the share of workers who do at least some of their work from home. And that's because maybe the high complementary jobs are a bit more senior, but these all tend to be kind of like knowledge economy, cognitive intensive jobs. But this is potentially good because at least they're not fundamentally different from the jobs that might be disrupted. And also in terms of health, the share of workers who report physical difficulties is very similar across the two types of jobs. And so is also the share of workers who are in occupations that are very physically intensive. On the other hand, these high complementary jobs have a high level of, are more likely to be very stressful. And as we saw from other presentations, stress and can be also a factor in leading workers to leave the labor force, or might have implications for health and cognitive abilities. So overall, I would say the picture is mixed over whether this kind of shift in artificial in occupations might be beneficial or might be by itself encouraging longer working lives just by putting workers in these other categories. Okay, another thing that I mentioned is that we can think about older workers now, but we also need to think about future older workers, because if AI takes a long time to come into the market and cause shifts in the distribution of jobs, workers who are now prime age will be affected differently from young workers. And we need to think about how they're going to adjust, and hence how that's going to affect their older age. And obviously there is no clear answer to that because this is something that will happen in the future, but here what we do is that we just take routine bias technical change and automation as an example. And what we do is that we look at workers in different birth cohorts from 1980 to 2000. And basically, most of the disruption was in manufacturing employment. And what we show is that older workers, so cohorts that were 50 to 45 in 1980, predominantly over time moved to jobs that had a lower wage relative to manufacturing. Workers who were in the earlier part of their prime age kind of moved both to higher and lower wage industries. And then younger workers who, as we've seen, have a higher fluidity in their labor market experience were actually much more likely to move up the income distribution to industries that have higher wages. So that's why we have to really think about this impact in a dynamic way and potentially with a multi-generational lens. The last thing, as I said, is potentially other channels through which AI might affect labor market decision, and this is the equity channel. So that if we think of owning stocks in tech companies or just broad companies that might benefit from AI and the dividends being linked to the returns of the companies, this might increase returns to wealth. And obviously only those who own equities might benefit from this. Older workers or those who are about to retire by having 401ks or IRAs or just their own stocks, they might have more equities, and so this would mean that they would benefit the most from returns to wealth. And of course, as we've seen from other presentations, the link between wealth and retirement timing is a bit ambiguous and multifaceted, but I think here what we want to do is just highlight this channel and also highlight the fact that it's going to be highly unequal because even in each age group, not everyone has stocks, basically. To conclude, we saw that older workers overall are less likely to make career changes and hence potentially adjust to labor market disruption. However, conditional education, older workers have a higher share of employment in the high complementarity jobs that prima facie are more likely to benefit from AI. And some of the features of these jobs are age-friendly, but others are not necessarily, so the picture is mixed. However, an analysis that only focuses on current older workers misses the picture that future generations of older workers might have a very different labor market experience in adjusting to structural change driven by this technology. And potentially there are other channels through which labor market decisions might be affected, such as returns on wealth. Finally, just a word on policies. Are the kind of policies that would be advisable are potentially those that both create a kind of safety net for the workers who might fall through the cracks or might be affected most negatively and cannot readjust, and also encourage the acquisition of new skills and essentially promote the ability to adjust by moving to other occupations that might be benefiting from AI, but also might be more age-friendly. And these policies are kind of generic, but it's important to also target them specifically to the kind of age group that might be most affected in different ways. So thank you very much.